We go on with the lecture on linear regression, and the next topic are more specific issues of the regression. So the first one we will see in this video is the use of qualitative variables or categorical variables. So a categorical variable is a variable that takes values that cannot be assigned a numerical value. So for instance, male or female, or the color of whatever, or any other variable that cannot be assigned a numerical number. So we can distinguish two cases, one with two possible values and with more than two possible values. Okay, so let's say that we have a variable that takes the values male or female. So what we will create is a dummy variable that will take the numbers, the values 0 and 1. So 0 if it is male, 1 if it is female. And then we fit in our regression model this variable, so we will have beta 0 plus beta 1 xi, where xi represents the gender of that person, plus the residual. So actually when the person is female, then we will have beta 1, because beta 1 is multiplied by 1, and when the person is male, we will not have beta 1. So actually this regression model is equivalent to beta 0 plus beta 1 plus epsilon when the person is female, or beta 0 plus epsilon when the person is male. So here let's say that we have some number of observations for males, females, and then this would be the regression line that we are fitting. So yeah, actually it is important to note that beta 1 is the average difference between males and females. And the encoding of 0 and 1 is arbitrary, so we could encode in any other way. So another very common way is -1, 1. So now the effective regression would be beta 0 plus beta 1 if the person is female, or beta 0 minus beta 1 if the person is male. So for the same data that we had before, the fitting is almost the same. The difference between now between males and females is twice beta 1, and there is an interesting effect, that is that beta 0 is the average when we ignore the gender. Here the mean when we ignore the gender is beta 0 plus beta 1 over 2. So yeah, the interpretation of the coefficients is different, but otherwise the quality of the model and the regression is exactly the same. So here we have an example where with this data, with encoding 0, 1, we have an intercept of almost 0 and no significant value, and beta 1 is 2.8 and very significant. This is the quality of the model, which is pretty good. And when we use the -1, 1 encoding, then now the intercept becomes significant and beta 1 is divided by 2. So and the quality of the model is exactly the same. So it is only a matter of how to interpret the coefficients coming out from the regression, but otherwise the encoding of 0, 1 or -1, 1 are totally equivalent. Okay, so let's say that now we have more than two values, more categorical values. So let's say we have three situations, A, B, C. So the incorrect encoding is by using a variable that takes the values 0, 1 and 2. So 0, 1, 2, so let's say that we define this dummy variable. The estimate is this 1, and the p-value, it is significant, but we can do much better. So here the r squared is or adjusted r squared is 0.15. So let's see if we can do it better. So the right way when you have m levels for a categorical variable is to create m-1 dummy variables that take the values 0 or 1. So let's say that we have ABC. So we will encode A as 1, 0, B as 0, 1, and C as 0, 0. So now with these new two variables, we have this regression model that is beta 0 plus beta 1 x1 plus beta 2 x2. And then depending on whether you have an ABC observation, then your actual model would be beta 0 plus beta 1 if it is A, because A is encoded by 1, 0, so you will have beta 1 but you will not have beta 2. Then if you have a B, it is the opposite, it is 0, 1, so you will have beta 2 but you will not have beta 1. And if your observation is a C, then you will not have beta 1 neither beta 2, so it will be just beta 0 plus the epsilon. And then the same data as before goes up from 0.15 to 0.44. So if we think of these data in the new space defined by the variables x1, x2, what we have here at the 0, 0 are the C observations, and then in x1 we have A, and in x2 we have B. So it is equivalent to fitting a plane within this x1, x2 space. Okay, so this is all for the categorical variables, and see you next time.